difficult topic to deal with, given that we always assume that parallel platforms are more rigid and more stiff than serial counterparts, although nobody's ever proved that. Nobody's ever actually demonstrated that. And I think the existence of backlash speaks volumes about how maybe they're not so full of mechanical advantages as has been described previously. Your work certainly outlines the presence of backlash destroying the potential for precision motions. And in my work with planar parallel platforms, we've come up against the issue of backlash, and we've not been able to come up with any solution. So this, I think, potentially offers the research community in parallel mechanisms some very valuable insight. This notwithstanding, I, of course, have some complaints about your thesis and some observations and some questions. And while I'm going to be rather picky, I don't want you to take offense to this. It's simply that I want the document that you submit to the National Library of Canada to be the very best document that you can possibly produce. And I'm hopeful that my criticisms add to it and don't detract from it. So I'll give you my observations. I'll start with very general observations based on the presentation of your thesis, and then get to more specific theoretical issues. So in general, after going through all of the thesis, I noticed that in your figure captions, there's sporadic capitalization, almost random capitalization of the captions. Additionally, in the table captions, my understanding of a academic document is that figure captions and table captions are sentences that describe the figure or the contents of the table, and so they begin with a capital letter, and only letters that are capitalized in the caption are proper nouns. And I think you should review your captions to get rid of the seemingly random capitalizations. And additionally, you should give a careful reading because only some of the captions are punctuated. This occurs with the table captions and the figure captions. And of course, I prefer to see them all properly punctuated with periods, etc. Additionally, in your references, did you do this with a Microsoft Word or the?
Yes, Microsoft Word.
There seems to be an issue with your reference formatting. When you have a single author, you have the last name, comma, the initials, and then the year, and then the title. When you have more than one author, invariably the last author, instead of last name, comma, initial, it's initial and then last name. So, and this is consistent through all your references. I don't know if this is a Microsoft issue, but you should go through that and make sure that you have uniform. I've indicated it all in the text. I'll give this back to you.
Yes.
Also, there are some errors in the names in the particular authors in the references. I've indicated them in the text, and also there's some errors in the titles of the papers. So I've outlined those, and at least to the best of my understanding. Then the last general comment is the figure that you have on page 25 and 26. You reproduce these figures later on as figure 4.1 and 4.2. And the difference being is that you have the reciprocal screw directions given. And I prefer figure 4.1 instead of figure 2.1a and figure 2.1b, because really the only difference is the direction of the reciprocal screw. And I think you could likely get away with using figure 4.1 on page 25 and figure 4.2 on then there's, well, this is sort of a philosophical question, and you're going to be a doctor of philosophy, so I think you should reasonably be able to deal with a philosophical question. The title of your thesis and the implications of what I'm going to be saying are a philosophical debate. But you say that your title is Backlash Reduction using actuation redundancy for planar parallel manipulators. That implies all planar parallel manipulators. And I purposely showed this morning in my talk that there are over 1,600 possible architectural configurations that are all different, that contain 3 legs, where each leg contains 1 active joint, and each leg also has 3 independent 1 degree of freedom joints, and there are over 1,600 possible topologies. Your approach applies to 2 topologies, maybe 4. So I consider this that there's something missing in the title of your thesis. Do you have any comment?
Yeah, I agree with you. I think I should add for the RR and RPR, this is what I'm looking for in 2 of the 16,000. So
yeah.
it's more specific for the what I'm working on.
But in your defense, from a practical point of view, it would be arguably more practical to have symmetric 3-legged platforms where each leg is the same topology. I'm very, I like to do things in a very general way, but clearly there's, perhaps a lack of real pragmatic realism with the generalization, but I mean, it's nice to have it generalized. But I think you're right. I think maybe you should augment the thesis title to be very specific to the exam. So I think that would be a good plan. Additionally, there are 2 in your conclusions on page 122 to 127. You make your claims of originality. I agree with all of the claims, with the exception of the following 2. The first one, you outline in chapter 1, and this is your working area visualization for parallel manipulators. And what you do is, instead of rotating the working platform, the moving coordinate system to a particular orientation, you rotate the fixed coordinate system to a particular orientation. I'm not certain if in your research you've discovered Clément Gosselin's PhD thesis from 1988, but he has done precisely what you have done, but the kinematic inversion, which is really the same as taking A equals a matrix times a vector and saying, well, I've made a novel contribution by taking the inverse of that matrix and multiplying the right-hand side. I disagree. You may argue with me that your work is indeed novel and a novel contribution, but I think the community would agree with me that this work has already been presented, and what you have done in your thesis is an interesting kinematic inversion, but it's simply a kinematic inversion. And then, can you describe what you mean by, on page 124, you say the redesign of prismatic joints can be considered to be a novel contribution. Can you describe precisely what you mean by that?
Yes, this is what I concern is the redesign. But because the prismatic joint for the previous systems, they use the prismatic joint. They always mounted from the ends, from left to right. But the way I use it, I'm going to mount it from the center. If you write straight out, it will be 1.2 meter, and I will mount it in the center part on the one side. It will be to the center plate firm. So have a root joint and with the center plate firm here.
Yeah.
And the other side, I saw a lot of people they use the prismatic joint, they mount it here. But I'm going to mount it from here, and this part will always hang out. So this is relative length. It will ensure the prismatic joint have from if totally get in it will be 0, and totally get out it will be 0.6 meter. So that's what I'm using, the prismatic joint. It will ensure the prismatic joint have the branch very capable from 0 to 0.6 meter. So that's what I'm redesigned for the prismatic joint.
Is this a redesign of a prismatic joint? To me, a prismatic joint is a kinematic pair that restricts the motion between two planes,
yes,
such that there can only be translation in one particular direction.
Yeah.
And that is a prismatic joint. The details of the stroke length and the details of the geometry of what the maximum extension is are really details of particular prismatic joints. So is this really redesigning the prismatic joint? Is this coming up with a new kinematic pair that?
I would say no, but yeah, maybe I should say modified or just mounted in different way compared to original how to use the prismatic joint.
Yeah, I agree.
Yeah, I do agree.
Sorry for being scatterhappy on the notes here. I'm not as organized as I used to be. Here we go. On page 37, in the text of your page 37. I have been sort of trained by two very rigid thinking mathematicians, and rigid in the following sense. When you use a particular noun to describe a mathematical entity, the noun and the mathematical entity have to have precisely the same description. And this is again philosophically important. But in your text, you say that you demonstrate that the reciprocal product of two screws is invariant under reference frame transformation, and you give you set it out in terms of linear algebra operations, and what the result is it seems to me that regardless of the reciprocal product of all screws, it seems that in this particular instance it will always be invariant. And so how is this a demonstration and not a general proof? I guess what I'm saying is, I think you're underrepresenting what you are demonstrating here. You're not demonstrating. You've proven that all reciprocal products of all screws are invariant under coordinate frame transformations. And I think that's a very important contribution in your thesis. And I think maybe you should not say that it's demonstrated, but I think you should say there's a proof, and call it the QED at the end there.
I should get a paper.
Yeah.
Based on this theory. Yeah.
Okay, so that was, I think you should say that it's a proof. On page 40, and in your talk, you say that the cutting forces in these slow-moving material removal operations are 100 newtons. Is that a realistic value in practice?
I think so. That's one of the things we can afford. If we're cutting some materials, we have to afford a force. And I think the materials will give the force back to the material. So this is one case. They can afford maybe 200, 150. So I'm just using this force to test for the acting force for the mechanical for the end effect of manipulator.
I should have reviewed my previous notes from a previous defense about 10 years ago. But it seems to me that there was a guy presenting work done on a machine center, and the forces involved were kilonewtons.
Huge. Oh, okay. So it's huge. Well, sure. But I think they could afford a different force, but they still. I think for the same algorithm, it will still work. I haven't tried to use like 100 newton. I haven't tried over a bigger Newton afford, but I think we'll use the same method. It will work. But I could try to get a bigger force. Well,
I was just going to try to tie this into one of your conclusions, where your some of the actuation and elimination strategies are force and torque dependent.
Mm-hmm.
So is your elimination technique restricted to forces of 100 newtons and less?
Less than 100 newton after using the desired for the base and the elbow for the compensation. So it is lower than the 100 newton. Yeah, I think for all the cases, for the RR cases, it does reduce the amplitude more compared to RPR. And for the RPR, especially for the prismatic joint, is I think it's half 50 something. Yeah, depends. So I think maybe if I afford the like 1,000 newton, then I have to switch the larger motor hydraulic cylinder to afford the large force of torques.
So do you think that your actuation strategy is scalable?
I think so.
And also on page 140, you say something that I'm having trouble understanding, and likely this is just because I don't understand it.
Excuse me, which page?
Also on page 40, one of your assumptions is that there's no moment on the moving platform in the motion platform coordinate system.
Mm-hmm.
How can this be?
No moment. Because this is a very slow motion, and the force is afford in the plane. Is in the it is corresponding to 3 dimensions, but they have a force in the x, y, and the moment on z direction it is 0, because the way we apply the force, it will be always tangent to the trajectory and opposite to the motion, and we don't have any angle. The force is on the plane.
Right.
So they don't have a velocity, angular velocity.
But the planar platform on which the tool is sitting, in which the moving coordinate system is defined, you have the applied force, but you also have the reaction from the machining, the element being machined, but you also have the supplied actuator forces, which are being applied at 3 discrete points on the moving platform. These moments all cancel out?
Um,
I don't s-
Actually, they don't have any motion in my case. This is because the force is always on the plane. It's not like from the angular have angular from to the plane, so it will have afford the zero moment. They have a zero pitch as well.
I guess I have to accept that. I don't understand how that's possible, but I will move on. Concerning the modified the modified prismatic joint on page 47, figure 3.4. Revolute joint R1J or R1I.
R1, yeah,
The
R1.
one that's just at the entrance to the cylinder of the prismatic joint. Am I correct in assuming that the revolute joint can move the 0.3 meters to the bottom of the bottom dead center of the cylinder? So the revolute joint R1J can move 0.3 meters inside the cylinder?
R1J is right here.
Yeah.
So
But what happens if the displacement of the prismatic joint is negative 0.3 from that location?
well, 0.3 will get into the cylinder 0.3 meter, and the revolute joint will still stay here. So this is the point.
Oh, okay.
Yeah, so this is the part coming to the base plate firm.
Oh, okay,
The
that
base.
changes everything. I misunderstood that. Okay.
Yeah. So that will guarantee this will, if it is stretch right out, it will have a 0.6 meter, and once they are hanging in half of them, then 0.3. Totally get in, it will be 0. So this modified the prismatic joint will allow the length of this branch will be 0 to 0.6.
So you're changing the length between R1J and R1I and R3I.
This is always
So that distance
0.6.
changes.
No. This will always 0.6 meter, but this part it could totally get into the cylinder and totally get out. But I use this part as a relative length.
So can you put R3I on the?
This is R3I.
Or is R3I on the?
Sorry.
That's right.
This is R3I. Yeah.
So the distance between R3I and R1I changes.
Yes.
Okay.
That's right.
Okay. That makes things totally different. In your list of contributions, you don't really mention anything about page 84. On page 84, you generate null space vectors for the associated reciprocal screw matrices. Is this your theoretical development?
The null space vector?
Yeah.
Yes, we presented this null space vector in the CSME conference in 2010. And
This doesn't appear in your list of contributions.
yeah, I think this is the part of how do we find the composition elbow joint. This is important to find the homogeneous range intensity.
Yeah.
And but the constraint for the optimization, the method is very important too. They will guarantee the elbow joint torques always stay in the same side. This is how do we find using null space vector we could find the homogeneous range intensity of the system.
And you clearly have developed this
Yeah.
Method or the technique.
Yes.
So why don't you claim this as a novel contribution?
Yeah, maybe I should list in, but yeah, but I think that the other part maybe they are more important for the contribution. But this is a good idea to list out for the as a contribution.
I think as a tool for generating the theory in a general framework for backlash elimination using redundant actuation. I think this is a critical contribution. I think you cannot proceed unless you have this tablet. Just my observation. Maybe wrong.
Nice comment. It's a very, very nice comment. It's not negative. Add it to the list. For sure.
I think that I will stop at this for the first time.
Okay, thank you. I do a questioning in terms of two parts, the general comments and then some very simple specific things. As you can imagine, I'm going to ask you some optimization problem in the second part, but in general, I'm going to have a few comments about your thesis. The topic is obviously, from what I understand, topic is obviously important in robotics and in this field. And I know your supervisor, your former supervisor, has been doing a great deal and contribute tremendously in this whole field. And he's really established a scholar for sure. And so I understand your work is taking the result of taking his advice largely and turning into this specific piece of work, which I think is very important. But people in this examination process always say a lot of problems rather than the achievements, but don't take that too negatively. So the general comment is this. I have a little bit of problem to read your thesis, and then I said why I have troubles here and there. And so I think there is a problem in your typesetting. You're using Microsoft Word, and good or bad, people have different opinions, but in terms of the professional documents, the best thing people can do is to use the LaTeX rather than Microsoft Word. I think it's generally agreed that the LaTeX is much professional, not only for mathematical equations, but for typesetting of any formal document. But I'm not suggesting that you have to change it to LaTeX. Even within Microsoft Word, you can do a great deal of improvement in terms of typesetting. For example, the equations you type are still not too professional in the sense that you hardly use italic font. If you pick any books from the library, you can see the equations, how they type equations, and I think this is something that still you have a big room to improve. And for example, you have a plus, plus, minus, and a minus, minus, minus. These are not minus; it's a dash. It looks like 3 minus, like a dash line. It's not 3 minus. So minus is different from dash. Okay. So you can see there are lots of things that you can improve. Not only just make the thesis looking good, but also looks very professional and people would appreciate more. Okay. The other thing is perhaps the most substantial still organization problems of the thesis. At the very end of the thesis, you have a section which summarizes the results combined with contributions. Okay. I do have a problem with that. The best way is to separate the two things into two single sections. And you should put a single section, use a single section to put all the contributions as a single section. Don't mix them with the summary, because the contributions are the ones that makes this thesis innovative. So people would love to see how many things you created, how many things there are you claim new. Okay. And it should not be at the end of the thesis, rather at the beginning of the thesis. So you have a thesis organization, but before that, I think you should use a single section to highlight the contributions. Okay. So the work to do to revise the thesis in this manner is not great, because you can just take something out from that large section at the end and put it into a new section and polish the words. Okay. So that would make the thesis easier to access and appreciate your contributions. Okay. So these are the general comments. Now the algorithms. Okay. So the first thing that I would like to say is when you read you have lots of simulation results, plots after plots. Think about a case where you have something that is origin, okay? And you believe you do have something origin, and you call the novel contributions. How do you argue your contributions is novel? You have to compare with other people's work and show that your work is better, right? Unfortunately, the entire part of the thesis carrying out these simulations, you always show the results produced by your method. Okay. So to make that part better, you have to make a comparison. You have to show the results you create is better than anyone else. I believe in slide number 10 of your presentation today. Okay. So you give a couple of, I believe these are the ones that you believe they are most relevant. Okay. One is during 70s, and then there are something new, the last decade. And I believe these are things most relevant to your work, right? So why don't you compare their work? You have problems with these work, and you do yours, and to make sure yours is better, at least you show some comparisons. At least in this simulation part, you have to show the difference. Yeah. Now it's hard to ask you to change the entire part of the thesis, but at least you have to highlight some part of your work by comparison. Okay, so that's what I suggest. And the work is not wasting your time, because if you want to submit your work to journal publications, people always ask you to show the performance comparisons. I don't know if it's a common normal in your area. I think engineering papers, to convince people, you have to show kind of comparison studies. Okay? So it might be something that you should think about. Now, the algorithms that you claim that's your algorithm, I understand you try to do something above and beyond this least square method, because the least square solution is a solution gives you the L2 norm minimized, but does not eliminate the backlash, because it cross zero, right? So yours is to push the envelope up or down to make sure the entire profile is not changing the sign. Therefore, it's a constraint optimization problem, right? Now, and unfortunately, your problem is not convex, right? It's highly non-convex. That's, I think, the reason why you use fmin con. So the first question is, do you know what fmin con is doing? You just call the command, right? What is the basis on which that command was developed? What is the algorithm based on behind this command?
The fmin-con is suitable for nonlinear optimization, and the method is a sequential quadratic programming method. And for my case, the objective function is related to each point the torques, and because each moment I divided the trajectory into 200 intervals. So for each moment, they will provide 6 different torques of force because I created 6 joints altogether. And the torques is very related to, they have a lot of translation from the desired range intensity and chosen for the base joint desired range intensity, the sine wave equation. And in those equations, I have 3 variables. And the torques have the variables the torques have relations with the variables, and they have 3 branches. So after so many translation, I get the torques. It is not a linear question, and it belongs to the sequential quadratic.
And sometimes the fmin con does not give you a solution, right?
Yeah, sometimes it doesn't.
Do you know why?
Yeah, because once I run the code, they are showing is close to the singularity of the matrix. The matrix I'm using, so the chosen x0 is kind of not a good choice. So I switch.
So when you say x0, is it initial?
Yeah,
point?
it's an input value. Yes.
So the fmin con allow you to choose your own initial point, right?
Yes.
So each and every time when you change the initial point, you might lead to a different solution.
Yes.
So you have a problem to claim this is a global solution. You never be able to, right?
No. Yeah. This is a local minimum solution for the algorithm.
So you try another one, and then who knows? Maybe tomorrow you get another better one.
Yeah. So because this is a not convex function, so I think this fmin con is good to find a solution, a local minimum solution.
Yeah, but there are so many of them.
Yeah.
How do you know your work is the one that representing a good suboptimal? You never be able to argue that either.
Yes, but I did I present the result is not for one time running the program. I get the one. I compare 6 different kind of initial.
So I guess the best thing that you can do, no one can say this is a global minimizer. Impossible, right?
Yes.
And no one can try too many because it's not realistic. So what I can do to say this is something good, I tell you what you can do. You compare. You compare the best solution from the literature, and your local solution is still better. Then it's convincing. But until then, okay. So the last question, I promise you, I have only one question remaining. You have a lot of tables in that part of the thesis showing what if you start with 3 pulses, and what is the torque, right, etc., etc. You have 8 choices. So almost without exception, I don't know why. You can tell me why. You have 2 rows. One is the number of points, and sometimes you see very large, like 4,842 points. Sometimes you see along the same line, you see something very small, like 641. Okay. So these are the points that you divide the whole piece, right? You have a sigma, you have how many terms? Is that right?
Yes.
You have a sigma of 4,800 terms, or sometimes you have a sigma of 641 terms. Is that right?
Mm.
The number of points, n.
The number of points n, it is 201.
201. So what is this n, the number of points? What is that one?
Could you please tell me which page?
Any table?
Any table.
Any table you have always two rows of
Yes.
numbers,
Uh-huh.
right? And the first the number in the middle is the 8 or 2 or something like that.
Yes.
Yeah.
So in this row, it
Yeah.
is the value of the objective function, the value of the results, divided with the 201 points. This is not the how many. This is related the value of the torques, the minimum true value of
Okay.
the applied torques of force for each moment. The
So I
average.
think I misunderstood. I thought you have sometimes you have to divide the whole profile into more pieces. Sometimes you have less pieces. You're saying the number of terms is fixed to 201.
Yes.
And then the first row is representing the objective function value.
The first
Is that right?
one
the
of the-
first is combination, 8 different combinations. The second
Okay.
row is objective function value.
The second row.
Yes.
The objective
divided by
function value.
the 201 points.
Are these two things correlated?
The third one, the second one.
Yeah.
The third one is average absolute value of the torques.
So if
They
the
are
number
related.
in the up row smaller, that means the torque will be smaller. Is that
Yes,
right?
they are related to each other.
Now sometimes it's not true. Sometimes most of them are true. That's why I thought there's something I thought you can explain. In most of the tables, if the number you see up there is smaller, then the tau is smaller.
Yes.
But not every time.
I don't really agree with this. I think they are a little bit different, but
Yeah.
with the torques and the value of objective function, it is divided. I think it's a take a root square and divided by the 6. We get the torques.
So I thought these two numbers should be correlated.
Yes. That's
But
right.
I thought, I figured out which table. Too many tables to search. I thought one of them was not that in that case.
I hope it's
I
not.
have no idea why.
Uh-huh.
Okay.
Sounds like a typo. with
Anyway.
each one.
I will stop here, and next round I will ask you some very minor questions, if you don't mind. Okay.
Thanks.
Okay, thank you. I enjoy reading the thesis and particularly enjoy your presentation. Very good. And I always talk to my colleague, Dr. Wang. You cannot refuse the temptation for mechanical engineer when you learn school theory. And when you say the dollar sign is embedded in the equation, then the body is cutting here. Anyway, to be serious. Now, in your presentation, I guess you just follow Dr. Liu's question asked. You were trying to solve the problem, I guess use optimization, constraint optimization to be more accurate. And the algorithm you choose is a spatial quadratic programming. So when I first look at it, okay, you have least square approach, which is object function quadratic form, right? So quadratic programming will guarantee you to have a solution. But you have multiple terms, no longer the case. You have many small values. So my first question is, did you try global optimization algorithm to?
No, I didn't.
Okay.
This is the further work. I'd like to try some of the other methods.
It will be a lot efficient to try a global search algorithm, such as the leading general algorithm. I guess you probably, at least in the future work, you should mention. Because by nature, when you use algorithm, I guess it's a general comment. In your thesis, throughout your thesis, you mentioned, I would say a few thousand times, of F-mean count, right? Don't, you only need to use once. The use of F-mean count is just one of the functions within the optimization toolbox. From my perspective, it's an implementation issue. So you want to say, I use sequential quadratic programming, which is algorithm proved to be efficient and robust. And it's good enough to solve local minimization problem. I need to try different starting point to identify the global minimum. And in terms of how do you do it, I use a method of the toolbox, particularly use F-mean count. And if you through the word use F-mean count, it's just just out of the normal practice. Right? Academic work, they don't say we just use a piece of software to solve the problem. In your optimization problem, I'm so glad to see your slide 19. Can you bring it up, please? Yeah, this is exactly what is missing in your thesis, in your dissertation. Right? Particularly in your section 4.8, you divided the entire formulation of the optimization problem into several different sections. In one section, you talk about objective. In one section, you talk about constraint. And then you talk about the variable bound. I would suggest, as normal practice, introduce the problem formally to start with. Then spend, I guess, a paragraph and a sentence to articulate the detailed formulation. So without this, I guess all technical people with technical background are going to look for this. Right? So somehow I know this is good. Now, the objective function. What is the purpose of objective function here?
To find the smallest applied torque, of course, the energy.
So this is basically minimize the torque. Okay. And the constraint. What is the function of the constraint?
The constraint is I'm using to find the first point in the first position, and multiply by the second, the third, until 201 points. They always greater than 0. This means they always be stay in one side. If they are negative, they are all negative. If they are positive, they are all positive. If they are smaller than 0, then they will be rejected.
Okay. So what is the purpose of this constraint?
The purpose of this constraint is guarantee the no reversing time for the compensation elbow joint torques, of course.
Okay. There's a few, I guess, a few comments I would like to make at this point. First of all, you choose a sign function. You choose a sign function based on what consideration?
The sign function I'm choosing because we see the performance evaluation of no-redundant case and the pseudo-inverse case. The performance evaluation of the required torques is similar like the sign-Lee equation.
Okay.
So
great.
it's easy
you present very well in your thesis. So when you use a sign function, this function is chosen in this case not to control the value, but to better reflect the, I guess, the motion and relationship of the manipulator. So in optimization area, we use sign function too. We use normally to control the value vary between -1 to +1, right? So when we want to control the value to be, there are two technical words. One is no negative. One is, I guess, all positive. And all positive means there's no 0. So what do? You use a square term. So now, in this case, you control alpha. You measure alpha value. Alpha value has between 0 and 1, right? Why don't you just add a square term? The value will never be negative. Do you know what I'm talking about?
Yes.
Right. So you don't have to change this. You have achieved certain goal. And there may be a better, smarter way to do it. Right? This is normally in optimization. You want value no negative, you should sign square, x squared. You will never get a negative value. And this also translates into the work you have. The objective function is to minimize the torque. The constraint, the objective of this constraint is there's three options: control the backslash, reduction, reduce the backslash, or eliminate the backslash. So what you're can achieve now?
To be modest, I think it is reduce. Right now we can close to 0, but if for the further research I would like to push a little bit far from 0, so then I will say it's a backlash free. It's eliminate the backlash. It's backlash free.
Now my feeling is that your current constraint is in the territory of control the backslash. You just make sure there's no negative value. You're not minimizing. Minimizing, you have to add this term to the objective function, and it will minimize, right? So now you are controlling it. You can move one step forward and add a small, no negative term. Then you will have elimination. So now what will happen is you probably have to have 0 value. You will not cross the 0 point, but watch your curve. Sometimes you have 0 value. So what you can do is just add a very small, no negative number to this constraint. Minus, I guess, 100.001 or 1,000, 110 to 1,000. You will have no 0 value coming out. Then you can really claim in your thesis you are doing the work of elimination of backslash. It's very possible. It's just I guess you probably travel 10,000 miles. It's only about 1 meter you need to go to achieve this goal. And now I guess it's just the 0 value may show up. So you need to somehow in your thesis clearly state my objective now. This is my objective function. The purpose is to minimize the torque while eliminating the backslash or control the backslash. Because I don't really say the reduction. It is a reduction, but you don't say this minimization of slash. And I guess that's all. Thank you.
Thank you, Dr. Dong. Dr. Sun.
Yeah. In terms of notation and how we use it, I'll start with that because it seems like the pattern that we go through here. I'll have to say that I did have a little bit of difficulty reading through the thesis because of the notation. And I think it would be helpful to add at the very beginning a short paragraph explaining the notation. Like, as I'm going through it, for me, it's not always clear what a vector, what a matrix, what a scalar. So I don't think the notation in the thesis clearly distinguishes among specifically scalars from screws and vectors. Okay? Now, coming from a robotics background, my bias is to say everything that's bold should indicate a vector or a matrix or a screw. Everything that's not bolded should be a scalar. You will probably need to go carefully through all the equations because there's lots of problems with all of those. Try to keep consistent, okay? I'm not sure if that's the notation you want to use or not, but I would say somewhere in the first section, clearly state how you use notation, and then go through all the equations and use them consistently. Because otherwise it's a little bit of a guesswork. What should be what, okay? And let me just ask you one question, which I think you clarified with one of the slides, but just to make sure, I have a problem with figure 2.1, which I think you repeat then, it's 4.1, and it's again, let me see, make it clear for me, it's 2.1A and B, are those correct or not? I think what you have on the slide, if I'm not mistaken, that's slide 11. That's what I would have expected to see in the thesis. So this is probably just a notation thing. slide 11. That's where you show the RRR
Yes.
robot.
This one.
Okay, so now if you look on the left-hand side, see how the base joints are all on that triangle, and then come the elbow and the wrist joints, right, on your slide. Now look at your figures 2.1 and then 4.1, and I'm not sure if it's repeated again. See how the B2 and B3, I would say they're not where they should be. B2 and E2 and B3 and E3, they seem to be
Yeah.
reversed in the thesis. Like I would have expected to see what I see on the slide. Again, I'm not sure if it's just 2.1 and 4.1. I noticed it the first time in 2.1 and then I noticed it's repeated. So you're going to have to go through them and
Yes.
fix the typo, okay, wherever it shows up again.
This is, yes, I think I will, yeah, I'm trying to not really confuse for the actuated base joint
Okay.
and the separate picture for the actuated elbow joint for the associated reciprocal screw. But I think I will put them together and try to.
Okay, but okay, so would you agree with me that the 2.1 in the thesis is actually a typo? B3 should be where E3 is?
Yes.
Okay,
Yeah,
and B2 should be where E2 is,
Yes,
right?
that's right.
Okay, so I'm not sure exactly how many times you have that figure repeated, but it's probably one typo that propagates. Okay? Okay, so that's in terms of notation. I have a few other questions, again, robotics questions. Now, in your contributions, right, on page 123, 24, you say that one of the contributions, let's see, is a proof of the invariance of the reciprocal products to changes in reference frame, location, and orientation. Okay? Now, to me, I would like you first to explain to me what's the physical meaning of the reciprocal product, because, I'm not sure, I haven't really looked at the algebra of screws and how deep or if it has been proven yet, but I think in the robotics community, it's fairly well accepted that, wrenches and twists, the reciprocal product is invariant to coordinate changes. So I'm not sure that this is a new contribution. I'm just
I think I have in my thesis I have a proof for if you choose different reference orientation.
yeah.
And it will not affect the final result to finding the applied torques or force.
I agree, but what I'm saying is I think this is fairly well known in the robotics community, because the way I look at it, and I don't know if you agree with me, is that the reciprocal product between a twist and a wrench is power. So that's a number, it's a scalar. So regardless of the coordinate frame that I choose to represent the twist and the wrench, if you want to go with screw coordinates, or regardless of the coordinate frame that you use to represent forces and velocities, if you go with vector notation, power should be invariant of the coordinate system. So that's why I'm having a problem saying that this is a contribution.
Sure, I will check more information about
Okay.
things.
Okay, and then one last question regarding your objective function. Okay, you have two robots that you're showing. One that has only rotational joints, and one that has rotational and prismatic. Now, when you choose the objective function, you take the sum of the magnitudes of the torques, right? Now, again, there's a philosophical thing there. When you only have rotational joints, the philosophical debate sort of vanishes because everything is torque. It's measured in Newton meters. But when you have the other manipulator, you have forces and torques. And you sort of mix them together, and you briefly say something about it in the thesis. In one, I forgot on which page, I'll probably be able to find it. But then you say, okay, the way I'm dealing with this is I'm just going to use scaling factors equal to 1. Like, you acknowledge that there is a problem, but then you choose scaling factors equal to 1. Okay? I wouldn't even call them scaling factors, to be honest, but make me understand again, why did you choose them to be equal to 1?
First, this is the Wheaton factor. WF is utilized to make the torque and force have a consist unit, and doesn't matter this is 1 or something else. It will always, if the torque is big or the force is big, it will always it will not affect the value of the objective function. It will affect, but it will not affect which one is the larger one, which one is the small, the best results. So even if I choose something else, like the other number of the second factor, it will still give me which is the best. Will be, if I choose this one, it will always give me the lowest value of the objective function.
I am not convinced I understand what best or even good is. What sort of stick used to measure performance? Like, some of your actuators are at the base, some of the actuators are further down, right? If I understand correctly, in your objective function, all the torques, both from the base and from further away from the base, are in your objective function.
Yes.
So, like, I'm thinking now, if the robot moves, the actuators that are away from the base, ideally I would like them to be lighter because the structure has to carry those motors around, right? So then if they're lighter, typically they're capable of less force. So I may want to do some weighting there that says, the motors at the base should be able to do more of the work, and those further away should do less of the work. So that might happen, right? But then you get into even the bigger problem where the base is rotational and the one further away is a force. So, we're like looking at apples and oranges in some way. So I think you need to consider a little bit more careful how you mix them into a performance measure. I would say. Like if you were saying, like if the objective function would include the magnitude of the screws, that would be reasonable. And typically that's a very important reason why people worry about screws in robotics. And that's why there is a whole discussion, why should we use screw theory and not just go with like vector algebra? Because screw theory can keep you away from these issues. They have a very structured way of mixing rotations and translations, of mixing forces and torques in a way that makes sense physically. Okay? So if your objective function would have the magnitude of the screws, I would say that would be fine. But if I understand correctly, those are magnitudes of torques and forces. So,
Yeah, I didn't think about the wings for the elbow joint.
yeah.
And I'm thinking about in my case for the RTR system, because this P, the prismatic joint, is mounted right here. So the cylinder will not moving, it will moving along this like rotation. It will not moving with this center phase curve. So for the RTR case, we just have this part is a revolute is showing here, and the cylinder is moving inside here, so it's not carrying by the center phase curve. But for the RR case, yeah, I think it's a very good idea to have the elbow joint have a lighter, smaller motor to afford the smaller force of the smaller torques.
Okay, I think I'm good for tonight. Thank you.
So the title is on backlash reduction using actuation redundancy for P planar PM. So can you please specify a little bit on what type of actuation redundancy in your research?
It is an in-branch actuation redundancy. We set up the base joint as a desired value for the case to provide the force for the manipulator 100 Newton, and the elbow joint is a composition torques to afford the homogeneous range intensity solution. It will be a zero output the initial force.
So precisely speaking, you're using the base proximal actuation redundancy.
Yes.
To be more specific. And then when talking about the planar parallel manipulators, how many cases you have studied?
For the planar.
For generally for PM. So
for PM.
just two cases, right?
Two cases, yes.
RRR and RTR. So back to Dr. Hale's question. So why don't you consider a new title to narrow the research topic down? For backlash reduction using this type of actuation redundancy for this and that planar PM. So this can make the title more clear and specific. So I cannot agree more with Dr. Liu's suggestion on using latex. However, you have already used the word. I always believe that latex is way more better than Microsoft Word, as I said to you earlier. But you have used the Microsoft Word, that's fine. If we are be careful more, we can still make the presentation clearer and more beautiful. But for example, I would strongly recommend you to re-edit every equation in the equation mode. So Microsoft Word has the equation mode. For example, this is a good example. Minus, minus, minus. If you continuously have three minus, minus, minus. Actually, in this case, a dash, dash, dash. That's something misleading here. So please re-edit all the equations under the equation mode, or the floating window in Microsoft Word. That will make a presentation better and clearer. Also, back to Dr. Konstantinescu's suggestion, it's better to add nomenclature at the beginning to clarify everything. For matrix vector, we use a bold or some transpose. All of this should be clearly defined and uniquely defined. Okay. So back to the several last page of the slide, you mentioned the contribution of your work. Remember, you tried to compare your result to some others. You mentioned the other side of a coin. That's very good. You say higher cost for your method. So can you further comment on this?
This one, we and Siemens, they use the spring to preload the prismatic joint. But for my case, I have to use 6 motors for the RR, and for the RTR system, 3 motor and 3 hydraulic cylinders. So it will definitely increase the cost.
Okay. So here it's very nice to list the pros and cons with this type of a very general comparison. So why not consider a numerical comparison with selective method in the literature to show the numerical advantage of your method? For example, more reduction on the force or torque, leading to a comparable performance index. That will make your work more impressive. Thank you.
So that ends the first round of questions, and we'll begin with the second round.
Okay.
Dr. Hayes?
Well, I'll start with this one because it's just, it was bothering me the whole time. And this slide, and I was just scribbling it down because I was expecting somebody else to ask one. But if you have passive wrist springs, you selected springs with typically linear spring coefficients, even if they're torsional springs. So they're discrete values, and they cannot be adjusted. So if instead you have a small motor on the elbow joint, able to continually change its value up to the resolution of the encoders, is this not better despite the higher cost? I mean, certainly a Rolls Royce is arguably a nicer car than a Volkswagen Rabbit. But I don't know. That's just in terms of relative weights and relative worth. It may be interesting to contrive an example where you show that specific values for the linear springs can't accommodate a particular backlash reduction, whereas you're maybe a motor with a specific torque rating can. I don't know, just a thought. Okay, so regarding the formatting of the list of contributions, or your contributions, I'm given to understand that University of Victoria is sort of somehow a blood relative of McGill University, and I did my PhD at McGill University, and in mechanical engineering, we were required to, in the pages before the first chapter, to have a list of our novel contributions, and that way it was right there at the beginning of the thesis, and so it was dealt with. And while this evidently is not the tradition here, I don't know, maybe it's something to consider. And then the last thing I want to have, and where I go to school, the second round is typically a discussion where it's not necessarily one-on-one. Is that the case here?
I'm just thinking, no, I don't know. Maybe it's done differently in different faculties, but I would
Goes to the
this
second
way.
round.
The second round of questions.
It's still
Individual questions.
Okay. Then, while it's clear that certain algebraic operations in for instance, in vector spaces, result in scalar quantities that are invariant under the coordinate system in which the vectors are represented. Moreover, dot products, for instance, are always going to give you specific magnitudes. Cross products are going to give you specific vectors that are normal to the plane spanned by the given two vectors. And some of these properties are clearly invariant to coordinate system transformation. However, in the algebra of the screw representation of displacements and forces and torques, I am unaware of the proof that power is invariant. While it's obvious that power is invariant, I don't think that it's ever been proven using screw algebra, or rather screws projected into vector spaces and using vector space operators. At least I've never encountered it. So while I would agree that the proof necessarily must have its outcome being true, I don't think that it's ever been done in this way. So while it's novel, and however maybe its worth is debatable, but I don't think screws have ever been validated in this way, the screw algebra. And I think it is a useful validation of screw algebra to show that it's consistent with physics. I think that's it for me for now.
Thank you very much. Dr. Lee?
Two minor things to ask you. Very, very straightforward, I hope. Now, you use in thesis many places TAN2, and I understand it's a tangent 2, right? TAN2, do you know? Actually, it's a MATLAB command.
Okay.
You got it?
In the last
Yeah.
sentence.
Yeah. So I just want to make sure that you understand what is TAN2.
TAU?
TAN, tangent.
Tangent.
You don't know?
I didn't find it, sorry.
There's actually quite a few of them.
Mm-hmm.
For example, in the appendix, page 153, and on and so on. Okay. You can see this arctangent 2.
Oh.
Yes. In the middle of the page.
Uh-huh.
Do you know why people put the 2 there? Arctangent is a tangent, and the tangent is a tangent. Why tangent 2? Do you know why?
Yes, I think I did ask my former supervisor about this, but in this moment I forgot. It's
Okay.
a long time conversation.
That's fine. Yeah,
I'm sorry.
okay.
That's fine.
The other question is the question about the null space. You use a lot of places. You use this concept a lot. So maybe you can tell us a little bit more about this concept, which is obviously important. What is this null space? Just give a definition of null space.
Null space is a vector they have a matrix, and we always sometimes we can find a vector to translate this matrix. Sorry, the vector translates this translate this into 0.
That's good. Okay. So now, so you have a matrix, and if you're lucky, you find a vector, and you apply the matrix to the vector, you got 0, right?
Yes.
So let's do this thing in this extremely simple case. Just make sure that you understand it. Okay. So on the chalkboard, maybe you can write a matrix. I give you a matrix very, very easy. Okay. The matrix has only 2 rows. Okay. 2 rows, and it has to be flat. Okay. So start with 0, and then 1, 0. Okay. Row, not column. Okay. Can you use a different pen? We couldn't see that.
There's
Do I have
more
a
highlighters
pink?
there.
Maybe red or.
Yeah, okay. So there are two rows, 0, 1, 0. Okay. The next row is 0, 0, 1. Okay. So this is something cannot be simpler, right? Okay, so this is a matrix. Can you find any number in the null space? No, you don't do mathematics. Just take a look. Because everything is 0, right?
Yeah.
Almost everything is 0. Okay. So you don't need any mathematics. You just have a look, and you get 3 numbers.
3 numbers.
Right.
0.
Uh-oh. ABC, okay.
Just give me a minute, please.
Oh, no. I'm not intending to bother you that much, okay. So go back to this simple thing over that. Otherwise, we have... So you multiply the first row by ABC, what you get?
The first row by ABC
Yeah.
is 0.
You have
Oh,
1.
0, sorry, B. Sorry,
Okay.
it's B.
So B has to be 0, right?
Uh-huh.
So you put 0 there. Okay. And then how about the second row?
Second row
What you get?
is C.
So C has to be 0.
Yes.
Okay. So what's the answer?
So it's 0, 0, 0.
No.
Oh.
Because if it's 0, 0, 0, it's a trivial number. Because in the null space, we have to find something non-zero. Right?
Yeah.
Because if you have a 0 vector, of course, you multiply 0 vector by a matrix, it's always 0. So it's a trivial case. So you have to make the case non-trivial. What do you do?
Well, some matrix, they do have a null space vector, and some of them, they don't have a null space vector.
That's what I'm asking you. You have a matrix
Uh-huh.
of that simple. And I ask you to provide one number in the null space. Just one number. Has to be non-zero, right? Because if everything is 0, then it's trivial.
Yes.
So now you see that? Then you're almost there, right? So you got a B equals 0,
Yes.
C equals 0.
Yes.
Okay. So you can erase B and a C, right?
Yeah.
You just put 0 and then. So how about? So the key is to. The key is to just one number to get. What's the number there? Now don't go back to that corner. Don't. Okay.
Is 1.
How about the 2?
2. The 2 is working as well.
How about the minus 2?
I think for this case, they have any number could be.
So what you can conclude?
So it's
What is the null space of that matrix?
this matrix have one dimension of the null space vector, and in this dimension have a lot of vector could satisfy this function into zero. So they have infinite numbers of vector in this
So
dimension.
in your
satisfied
thesis, you're talking about matrix 6 by 3 or 3 by 6, is
3
right?
by 6.
So what will be the dimension of the null space?
3 dimensions. 3 dimensions of the null space. And in these 3 dimensions, they have a lot of infinite
So
number.
you can find the 3-dimensional null space. You cannot find the null space of this one.
I'm so nervous.
Yeah, don't worry.
Sorry.
Okay. That's why I asked you. Thank you.
Thank you, Dr. Dong.
Yeah, a very simple question. Have you heard the word dimensional, no dimensionalization?
No dimensionalization.
Okay. Your formulation to minimize the sum square of torques, right? It's correct. When you have the RR situation, you have only torques. When you have RPR, you have a force embedded. The best solution to do it, because you're trying to compare apple and orange, sometimes the relative magnitude of force and torque is going to influence the outcome of the minimization. What you do is you, rather than minimize torque, you minimize torque over torque zero. So you basically remove the dimensions. In this case, torque and force can be compared in the same equation. I don't know. So basically, you first find out in a particular configuration of your robot the torque and the force of all the joints, and divide those values from the T and F and T and F. And the optimization you carried out will have no impact, no influence from the dimensions. Just a quick comment. Thank you.
Dr. Shi?
I think.
Oh, Dr. Yeah.
Okay. So it's interesting. I'd like to challenge you a little bit because you're pursuing a PhD degree. So it's very interesting in our continuing areas. When we define a concept or introduce a variable commonly used, the name or terminology will imply something that's closely related to the physics or practical systems. So in MATLAB, that follows the similar line. You are always using fmin_conf. Could you please explain to us why the developer gave such a name, fmin_con, to this function? Fmin_conf. What does that mean?
Function.
So the function name, MATLAB function name is called fmin_con. Why the developer of MATLAB MathWorks give such a name to this function?
It is a function in the min-max solution with the constraint.
Okay, good point. So function minimization problem with constraints. Now come back to Dr. Liu's question on 10 or arctan 10 to arctan 2. So I'm just asking you, when you are using this function, you're trying to calculate some angles, right? Or, and then what will be the result of the result of your angle? It will be 45 degrees or 60 degrees or 140 degrees. And do you still remember the result?
I think we are using it the value is not a degree, it is into degrees.
Okay, it's a below half pi or over half pi.
It is.
You have some 110 degrees, right? So it's larger than half of the pi.
Yes.
So then you can try to guess. MATLAB has so many functions. A family of functions can cube and result cube. So this 2 may mean double the output range of the function. So your result will be within negative pi to positive pi. That's why you use this function. If your application specifies the output result angle will be within negative half pi to positive half pi, you will not necessarily use the function with two names. Thanks.
Just a little bit of time. Are there questions from the audience at all? Okay, so I'll ask the committee to leave now, and the audience as well.
Turn this off.
Take it out.
Take it out.
Or under.
老师好虐人呢。要不听他听节目？
对杨哥来说，好像他不能一直录。本来张辉那个就一直在。
好像没有一直录。录了吗？
录啊，当时是一直在录，我也记得。
不是，不是让他就是讲完以后就不录了吗？
是。
Very nervous about the question. I even forgot how to get the matrix function.
Oh, actually, A10-2. If you said I taught it to you, but you forget. To me, it means quadrant corrected tangent.
Yeah.
That's what Zuman said. It's the top 0 to pi. It's the bottom 0 to minus pi. It's quadrant corrected. But no, you did a very good job, by the way.
But I'm very stupid about that question. I forgot I cannot find it. But I'm glad I have.
Yeah.
It's 3D.
And Dr. Liu's question was the matrix. The first column is 0, 0.
30倍看看。
The space basis what?
光学变焦还是数码变焦？我估计这个很可能是光学变焦啊。还在录。啊不，2.5到62.5。卡尔蔡司。啊是1.8。这还是焦距应该是你2.5到62.5，那差不多就快有30倍吧。最大光圈1.8。有。蔡司的这个标识实在是让人有点费解。现在全打都不好，这所以。不允许放下去，免得你录音。我好想看看张辉当年那个录像，那录像我朋友吗？不在我这儿，在张飞那儿。
Really, you shouldn't. This is 100. I think she did a very good job.
Yeah, a good job.
Here to the washroom.
开一下门，就。就这，它有那个按钮吗？咱不知道好不好按，看看。Do you need any help?
Cheese.
Okay. 看一下 WiFi。哎，真好。所有人都在讨论奥斯威。第一个他问问题，我觉得也挺问的很多。就那个 Hayes。对。因为实在不能再问啥问题了。人家非常 nice 也。第一个人挺 nice 的。不过太犀利了。就当年 Curry 才犀利呢。第一个 power and energy 是吧 ？What is the difference between power and energy？ 我一下就愣了。但你会好像好解释明白，还不错。我再瞅了一眼石阳可以给戳一笑。还是功率是吧？
对啊，power
就是功率 ，energy 就是能量。
biological extension at 610.
你当时说好像一个 about time， 对，我靠，想了好半天。
为什么要在这儿？哦呀，对对是。
对，结果
咱们能知道吗？
能，当场宣布。5个结果，第一个是。
一般基本上都会通过是吧？
一般是。第一个是 accept with minor revision。第一个是什么都不用改。第一个什么都没有，是 minor revision。对。第三个是 major revision， 2个都是 fail。对。太紧张。
好的问题没答上。
要是在毕业之前，肯定大家都要折磨一下嘛，这必须。
太痛苦了，这种感觉。
要不然你说怎么能轻松PhD毕业而没有任何挑战的时候，这不可能。
我觉得他们的老师就是按规定，就是每一个人都要问是吧
？3轮问题。
天啊，必须问。
PhD 3轮问题。
是2轮吗
？Master 2轮 ，PhD 3轮。
还有几个还要答一遍？
没有，你已经完事了，刚才已经问了3轮了，已经没意识了。
再来一个 defense， 就那个什么。
Defense 2。
像我们毕业的时候，
这个拍的好沉呐，我看。
这是谁的？我也在担心我谁的呀？哦，菲利斯。还有他的那个。
对，他让我都把他拿。
就没事，不知道出一事咋干嘛。OK， 那我给他拿回去吧。行。哎呀，太久了，我反正实在不行再来一个。这个就是最后这个特别感觉是回答不了。特别简单的，其实脑子一片空白，都不知道是就完全不能记账。有时候我平时在看所有的那个normalization，就把它画成一个0到1。你们都会搞这个，我都完全不懂。没事，干嘛？回忆加我呀！回忆加我呀！现在才讲，你还有我号吗？太可怕了！我都这样，然后但是你没给你们邀我。没事，那个太紧张了，不知道无法思考。对，10。What kind of result are you going to give me?
I know what I'm hoping for. Pass subject to my revisions. Or that there weren't really sufficient objections that I would say it's major revisions.
Except the matrix question, how about the other questions? What do you think my answer of most of them?
Had good answers. I, of course, was biting my tongue because I wanted to answer the questions. Whenever you got asked a question, I wanted to say, this is the answer sheet, go this way, go this way. I had to really...
Are they going to vote or they just...
Yes, they vote.
They will vote.
Yeah.
So five people.
5 people are voting, yeah.
And if 3 to 2, then I can pass. Or not.
Usually it's a majority.
Usually it's majority.
Usually it's a majority, yeah. But they're just deciding how to pass you or to fail. And I think you'll pass my revision. It's my guess. But then
Do they sue people regularly, or they can give another chance to defend?
Talking negative now. I don't want to talk negative. But what I do hope to come up with is John, the external documents, said he had marked things in the theses. It's very handy to have marked versions.
Okay. Do you think he's going to give that to me?
Oh, yeah. Yeah, I know. John said he would.
Okay. How about the other examiners?
Try to get them all.
Okay.
Because it makes it a little bit easier to revise. But one thing that was requested there was use equation editor.
Yeah.
Do you have that on your version of Word?
Yeah, I did rewrite all the equations already, just I haven't put in the document.
Okay. And make sure they're very consistent. Okay. And also read one from Daniela was at the start of the thesis, define what the notation is. A bold is a vector, or it's a screw, or it's a matrix. And actually, I think a bold capital is a matrix, or it is a screw quantity. Bold lowercase is a vector. Like the wrenching tensity is W. Sometimes you're bold when you have them all as a vector. Okay, and then scalars are put as ordinary.
So we can go in. Did you have the signature form?
Yes.
Okay. It's here. The form is here. Do you have a minute to sign?
Yeah.
If I don't have a chance to see you, have a safe journey home. Thank you very much. Thank you for coming. Really appreciate it. Thank you.
Oh, maybe you should listen to what she has to say, please.
Okay.
No, it's okay.
Why don't you, okay, so, okay, yeah. We will need turning point part two, right?
Yeah, you also will.
All right, okay.
So you can mail everything.
Email.
That will be great. I will send you a guideline for the reimbursement.
You must be dying to know. Congratulations.
Oh.
Your thesis has been accepted with minor revisions. So
Thank you so
Be
much.
the first to congratulate.
Thank you.
Thank you very much.
Congratulations, Dr. Mao.
Congratulations.
Thank
Yeah.
you.
Congratulations.
It's an exciting
Thank
time.
Congratulations.
Thank you.
Good.
Congratulations.
Thank you.
Welcome to the PhD club.
Welcome
My
to the Academy.
Yes, welcome to the academy. I used to live in an apartment building, and my neighbor was a medical doctor, and he had a daughter that was the same age as my daughter, Shannon, and they were maybe 4 and 5 years old, and they were sitting out in the hallway playing. It was a very relaxed apartment building. There were 8 people living in the building. And the children were playing out in the hallway. Both our doors were open, and I was sitting in the living room, and I could hear them talking. And the girl of the medical doctor said, "My daddy's a doctor. What's your daddy do?" And my daughter said, "My daddy's a doctor too, but the useless kind."
She's so funny. I like the joke.
You did well.
They were so nervous too.
Oh, yeah.
Nice to meet you.
Nice to meet you. See you down the road.
Thank you very much.
Thank you so much.
Thank you, Dr. Liu.
So that's it. You're done.
Good.
You just have to do revisions, minor revisions and modifications.
Yeah.
I haven't marked the pages, but where I found things that are question marks or perhaps wrong, I've indicated them in
Thank you so much with a lot of comments, and it's a very good suggestion for for the correct titles and some
But I really appreciated having the pieces sent to me in a binder. That was very nice.
You're welcome.
And right here.
December 5. I will keep this until the revision is done, and I will sign after everybody signs.
Do I need to come to your office?
Yeah.
Okay. I will come to your office.
Sure. Why don't we?
Maybe we have a picture with Dr. Hayes together. Thank you so much for.
You're very welcome.
Yeah,
Sure. Hey. Oh.
You're on. Okay. I won't get to run too soon. All right. Actually, I'll be here tomorrow for Christmas party. Oh.
Thank you.
Okay. I know. Okay.
Beautiful.